Hey everyone, welcome back to our podcast. It's your host Shivam today, and today's episode is going to be an exciting deep dive into the world of prompt engineering and LLMs. We have got a fantastic guest lined up for you today. Meet Anubhav Roy. I have been personally following Anubhav's insightful content on LinkedIn for some time now, and I can't wait for all of you to hear firsthand from the man himself. So let's get started. Anubhav, so how did you get into this generative AI fit?
Hello, Shivam, and thank you so much for having me here. It's great. It's an amazing pleasure to be here, and hello to your audience as well. Thank you for joining into this one. Means a lot to me. So thank you again. So yes, how did I get into LLMs? Well, getting into LLMs, that's actually a very funny story. I'll tell you. This is during the time when I was pursuing my master's at Jadavpur. The year was 2020. So you know what happened. Unfortunately, that we hit COVID. Um, a lot of people, unfortunately, suffered losses. Some of them even personal. So during that time, a lot of things got delayed, especially the educational institutions. Anyway, had to hustle through that bit, and I was also working at a startup at that time. So I would basically do my classes during the day and join that shift during the night. So that was anyway. So it was during that masters I actually often got was the one who would be the, get to those assignments at the last moment because handling a job and a master's degree is difficult. So while juggling between those, we had to do our summer assignment, and the summer assignment everybody gets to choose a topic. So I mean, of course, like every other time, I was the one who reached there at last, and pretty much the only two options available was 5G technology and generative AI. So you know what I chose.
Yeah,
So yeah, that's how this all began. The last two chits in the jar and a master's thesis to back that up. So yeah, that's how my journey began.
that's really great actually.
It,
So could you tell us about any AI or LLM projects that you are currently working on or you have worked on?
sure. So I mean, one of my personally one of my favorite. I'll actually mention three here. So few of my favorites would be one that uh, when I was actually new to this thing. Getting into prompt engineering, I practically learned it from the legend of machine learning and deep learning, Andrew Ng. He has these amazing courses on his website, and that's practically where I learned. So I was all eager when you learn something, you now want to apply it. So that's a project, and I sort of ended up building building a agent, a custom agent, which was sort of, from if you would say, it was throwing the back built on the backbone of basically React prompting. Using an LLM, we could essentially perform natural language queries on pandas data frames. All right. And the way this would work is basically it would allow the user would type compose a query. Based on that query, the agent also is being sent context on the type of data frames, and I'm talking multiple here, that you can have as many data frames as you want. Context of the data frame, which is essentially the data types it has, the column names, the and a few sample data in those, so and all that. So basically using that information, you would allow the LLM to generate pandas code, which you would execute and basically get say a snapshot, or you could generate a pie graph and all that. So that's one project which sort of stands out. And recently we did have a publication of the same as well in Springer. So yeah, uh, that's my very recent publication here. That one definitely stands out. Another one which I really loved, and it did really teach me a lot. Personally, I did learn a lot about it is when we started fine tuning foundation models. So uh, we and it gave me a very deeper understanding behind perplexity and loss, how these two are equal. I mean, almost the two metrics that you just cannot ignore when you're fine tuning. So this was a amazing insight that I got. Fine tuning does have a very high bar on the quality of training data you give. It is very susceptible to noise, but one good thing is that you of course can work with a small, very high quality data set, and you can do fine tuning very easily. Like, I mean, just maybe a couple of 100 rows, max 1,000, will just do the trick for you. So that was another. It was really a learning experience. Third one is when we are building, foundation models ourselves. So handling the back propagation that gets to me all the time. So that is still something we are trying to optimize on. So we'll keep talking in a future episode on what happens, Shiva, on
Definitely,
that.
definitely.
Yeah.
So exactly, like so mainly there are two key terms. Like one is the prompt engineering and another is the fine tuning LLM. So if I ask you, like, how do you exactly do prompt engineering?
Okay, so before we get into that, see, you have to understand that even prompt engineering has to be divided into two sort of sub branches. One is, when you're trying to do a one-time task, which is not sort of repetitive in a manner of speaking. What I mean by that is when you're, say, trying to get a deterministic output from the LLM. It could be scoring an answer. It could be, say, summarizing certain text. When you're trying to get a deterministic answer, that's a simple structured prompt. I mean, you'd have to usually, typically, I have seen LLMs work better when you're giving it examples rather than, just instructions. And that is something so you can practically, just say, give it a sample input output, and just start the prompt with, your task is to do the following with a sample input, sample output, and you're done. uh, LLMs respond really well to that, whereas if you were giving a lot of instructions, it often tends to, confuse the order in which it should actually execute, and often they are not as effective.
Great, great. And what about the next, like second case, like where you consistently need things, like you discussed the
Yeah,
first one.
yeah. So about the other one, which is so that is when, you are trying to recursively solve a problem. Say, that's say the kind of prompting that comes with, say, chain of thought or React. The say Because when you are asking a complicated question, you have to start or perform your generation or break it down into multiple sub steps. All right. So React is, I mean, very effective on how it does that. Is basically, first it allows the user to ask a question, then it breaks the question down, and then it will individually sort of proceed sequentially on each of those broken answers. So since most of the APIs on how we interact with LLMs, they are usually stateless calls. So it's just a matter of, concatenating each prompt after each answer that you get from the LLM. So you sort of end up making a chain.
Okay, okay. And how do you let's say use the word fine tune this particular prompt. Let's say you're in a recurrent usage use cases, a different kind of inputs will be passed to your prompt. So how do you finalize like whether this prompt would work best in this particular case or this prompt would work in this particular use case?
Sure. See, there are of course I mean metrics on how you have. So first, of course, you have to. I mean, I'll always say, as Andrew Ng even says it, that always start simple. You know, break it down, break your problem down into as many sub steps as you can. Like, say, for example, let's say that paper which I recently published. All right. So mm, say you want to perform, or say you have two pandas data frames. One is, say, the each each data frame could contain, one is on the cat, say we are doing Tata Motors. All right. Now uh, one data frame is about the cars that Tata Motors has, and the second is on the monthly sales. All right. Now you want to essentially, be able to ask it that, tell me the sales for Nexon in the year 2020, for the month of July 2023. And how you would approach a problem like that is basically you would break it down. Now you start small. What you do is you take your initial data frame and you give it. So how do you structure a prompt like that? So here, of course, if you give it extended instructions, it's not going to understand. So now it becomes helpful if you actually give it uh, input and output examples. So you give it examples of similar user queries that, if the user tells this, then you start with a small chain of thought. And how you do that is you start that, since the user is asking this and this, we have to filter on this column. So you, in the first few lines, you allow, in of your simulated output, you allow the LLM to actually think about what it is going to do. In the in the next few lines, you exactly practically provide it with the, say, since it's pandas data frames, you provide it with the exact Python code to do that operation that it talked about. And finally, you provide a conclusion on what was done with the final answer provided. So you have, because, and this is really important, because and why I always insist that whenever we are building an application, we have to show the flow, is because at the end, LLMs are really generating machines, right? So you have to have sort of a check for hallucination even on a live, on something that has gone live. All right. So say it is telling me the total sales is, say, 2 lakh 30 rupees, or 20 lakh 30 rupees, whatever, 30,000, whatever. So how do I know that it arrived at the right answer? And that's how it is important to be transparent, where you actually show your Python code, the kind of operations it did by executing that code, and your final answer. So there's sort of a trace back.
Yeah, definitely. So, can you please more elaborate on the part where you were mentioning how to evaluate the output that has been generated by the LLMs?
See, of course, that depends use case to use case. Like in say, when an agent is there, you of course want to uh, test it by giving it different kind of natural language queries, and determine the output that the generated code is generating, and match it with an expected answer. And that kind of evaluation is sort of easy, because you what to expect. It gets tricky when you are mm, designing an application which is going to be, say, generating longer texts. All right. And we have, of course, metrics for that, who's like, We have scoring methods. We have blue score that is quite good. So there are similar metrics as well. Another thing that a lot of I mean industry people in the industry do is they keep a golden set, which is sort of I mean, basically, it is what do you say, generated by human annotators. Say, some room, I mean, 100 or 200 rows of text. Like, what if given such kind of answer? What would the human answer? And be, or say, an expert in that particular industry answer, and then basically take the LLM generated outputs, and they would do basically something very similar to a mixed bag of words approach, so that because LLMs can vary vocabulary, so a mixed bag of words approach sort of helps you eliminate that problem. So these are few techniques, I mean, I have used in the past.
Okay, great.
Yeah.
So, you mentioned about like there are blue score and there are other KPIs that where we use the human written answers and then we use these scoring methods to
Yeah.
evaluate the output. But what about when you build the product and the product is live now? It is in the production where you don't have your human output. So how do you evaluate the quality of your output that is being generated in production?
Yeah, that is why I said that no matter whatever you're doing, say it is very important to keep that kind of transparency on how that LLM actually arrived at that answer. In case, and like for say for example, let's take something as simple as text summarization. Okay, now, most of the people, and this is where responsible AI also comes in, because see, you can ask, go to I mean Bing, or basically the Chat GPT website, and you can give it a piece of text. I think they allow up to 4,000 characters. So you can give it a piece of text for free. I mean, for just under 4,000 characters, and it will. You can ask it to summarize it in what, maybe 100 words, and it will do it for you, no problem at all. But but so where does we as people in the industry make a better model choice? How could we make this better? By showing that by introducing an intermediate output. What that intermediate output could do, something really simple, that provided text you gave, it could just say that it could show its work on how is it exactly summarizing that text. Little steps like this, that say it used the first line of that summarized text was basically generated by, say, the first three lines of the text that you provided, or similar. That is something we definitely strive to keep in all our products. That almost every product that we build, sure, it does cost us a couple of extra calls than it would say uh, cost us to not show the work. But sometimes you just cannot compromise with certain things, and transparency in AI is something we don't argue with.
Great, great. Okay. Another part, like most of the time we get the question is like since we are running lots of iterations, so and we are running iterations across the models like Chart, GPT, BART, Llama, and some that like other models are also coming.
Yeah, yeah.
So how do you like first how do you document it? How do you document your insights so that you can make some conclusions after like a month or when you are putting in a production? How do you document your insights and all the iterations, input, prompt, output model, all those things? How do you document it?
So, I mean, we do internally, of course, keep whenever we are working on an R&D project, we of course do internally keep notes on what happens. There are we try to follow the agile structure. We've seen that work really well, and you could of course link the cards to say somebody has a detailed insight on something, they would link their say Word doc to that particular card. So you could do that. So that is one very effective way of collaborating. Of course, uh, I mean, cloud providers have also, come hand in hand. And I do tell people that, while people, appreciate the LLM, one silent person who often goes unnoticed are the cloud partners themselves. The only reason people are able to access these large language models, do all kinds of experiments, create microservices left and right, do all of these things are really possible because, say, cloud providers like Azure, Google, GCP, AWS, all of them are actually creating, uh, creating environments, creating workspaces that allow practitioners or people like us to experiment with almost zero hassle. They uh, making almost everything a managed service takes a lot of headache off, and we can focus on the more important bits like working with models, who- testing it with more data, and that has so yeah, I do also. I mean, so one silent partner who does go unnoticed and deserves that appreciation is the cloud providers themselves.
Great, great. And like, since we have been discussing a lot on the prompt engineering, so let's say for overall success of an AI project, what do you think, how much important the prompt engineering is?
Prompt engineering is definitely great. I mean, English is the next programming language, and I was really motivated by this saying in a Microsoft presentation I had heard. So, and that is being becoming true more and more by every passing day. Very soon, coding will probably be something of the past, and uh, we'll be able to intuitively build things by just interacting with bots.
Okay. And like, since, okay, if it is important, then what do you think, what are the key challenges of prompt engineering as of today?
Prompt engineering. I don't think prompt engineering has any challenges. What I what I mean definitely do believe in is that there are just so many wonders we are yet to discover.
Definitely. Okay, let me rephrase my question. What are the challenges you face when you want to implement the prompt engineering framework to build your AI project? Execution part, what are the challenges?
Mhm. I mean, with a prompt, of course, it's really important to have a very good prompt, and you can only learn by doing it hands-on. Uh, sure, I mean, any course would help you get a boost, get a basic sense, but you only learn when you do. So every project is unique. Every use case is different, and uh, I mean, one of the only challenge I think that a prompt, I mean, you can face with a prompt is that you're not designing your prompt well enough. Like I'll tell you, say for example, okay, I'll just take us once more back to that example when we are doing natural language queries on data frames. So it is really important to be precise and exact on what kind of information that you're providing for something like that. Like say for or what kind of output are you expecting? Like say for example, you anybody would like to say provide the LLM with their data frame entirely, and ask it to just give it what it wants. But uh, upon experimenting, we saw that that was not really, I mean, upon giving it data like that, we saw that we were not getting the desired results. And it was only when we discovered a workaround that, don't make it generate the output, make it generate the code to get the output. Because the kind of base model we were using back then uh, was really great at generating code. I mean, it was better at generating code than actually analyzing tables. So as I said, it's really important to know what you're working with and what you want, how what kind of outputs you want to generate to get your final answer. And
Definitely.
once you figured both these two out, designing a prompt is going to be a walk in the park for you.
Great. Great. Okay. Moving to the end of our podcast, the last question. So, what do you think, like when you are building an AI product or AI project? So, what are your key goals to meet?
Okay. Um, See, there are for any AI project, or I'll just actually say it out loud that for anybody in the AI industry who's building a product, the three things that they just have to definitely stick to is first, the it should basically answer three questions positively. First is this product that I'm building, is it fair? um, the second question should be that is this product that I'm currently working on, is the output, the way it is actually getting the output, or the way it is generating the output, is it transparent? And the third one is it really solving the problem in the most optimized way possible?
Okay.
Yeah,
Like
these are
just
the
one follow-up question. How do you make sure that it solves the problem that you wanted to?
I
Like
mean,
the third point, how do you make sure that?
so any product should be, you have your examples of inputs and outputs, right? Whenever you're
Yeah.
working with AI, you have your input output samples. Of course, supervised AI, supervised learning, but yeah. And just to clear the air here, when we are talking AI, we actually mean machine learning, to be specific here.
Okay.
All right. Yeah. Even generative AI for that matter. That's also included here. So whenever you're doing that, you are of course presented with in sample inputs and outputs. So the question is really, are you getting your expected output? Like say for example, I'll actually clarify that with an example. All right. So say for example, you're building a classifier, or yeah, all right, you're say building a multi-label classifier. All right, now what that multi-label classifier is doing is it is going to basically predict or classify the diseases that a person could be suffering from based on their clinical records. All right. And when I say suffering from, I mean things that have not been identified in the test. Like say, for example, if somebody is seen to be losing weight very quickly, their white blood cell counts are off the chart. Uh, you would suspect that it might be a case of cancer. And sometimes it's just better to be sure than mm, So, I mean, so you would, of course, want to do a test, but a lot of times these could go unnoticed. These patterns which have been accumulating over time. Not just cancer, a lot of things like motor neuron disease and all of these. So, whenever they are accumulating over time, and you're trying to build a classifier, what is the one metric that you will try to keep, focus on? Any guesses, Shiva? That one metric.
Uh,
When you, since it's a classifier, so the metrics will be, say, precision recall and F1 score.
hmm.
What is that one metric you will be focusing on? All right, we'll just remove
I think
F1 score.
mostly in classifier, I would love to focus on the precision actually.
Well, Shivam, you will be wrong here. And why I'll
Okay.
tell you. Why I'll tell you? Because, see, you want to keep the, sure, precision is important. I'm not saying it isn't. And you, of course, want that to be as high as possible. But here, your main focus should be on the recall. Why? Because, say, somebody could be suffering from cancer. All right, you would want your classifier to predict that than not. All right, so a false positive is acceptable, but a false negative is not, because a false negative means somebody with cancer could go undiagnosed, but a false positive means, sure, I mean, it diagnosed it with cancer, the doctor reviews it, prescribes a couple of tests, it comes out negative, no harm done.
Okay.
Yeah. So
Yeah,
that
that
is
makes
what
sense. That's
that that
totally
does
logical.
that does, right? And that's what I'm saying, that it is important to know what you are building and who you are building it for, and does it solve the purpose that it was designed for.
Makes sense. Makes sense.
Yes, yes,
Yes, yes, exactly.
yeah.
Okay, guys. So we learned quite a lot of the steps and like techniques, how we do prompt engineering and how we solve the key challenges. And like Anubhav said, great examples in like the Tata use case and then the last cancer use case. I'm sure you guys must have got lots of new insights today. So thanks a lot, Anubhav, for joining us today and sharing your insights. Thanks a lot and have a great day.
My pleasure. Thank you. Thank you so much. Bye bye.